Semiconductors are the perfect materials for producing electronic devices essential in our everyday lives. In this video, we will explore how semiconductors are produced. Within the semiconductor supply chain, companies are often highly specialized to be competitive in the global market. This also applies to the production of high-purity semiconductor wafers. The vast majority of the semiconductor wafers produced are silicon wafers because they are used in the manufacturing of integrated circuits, or ICs. The starting material we need is some extremely pure semiconductor. They come in the form of wafers because they are thin, circular discs, although semiconductor wafers are usually much bigger than a wafer biscuit. To produce any semiconductor device, we need to precisely control the semiconductor's electrical conductivity. For this, we dope the semiconductor by adding a controlled amount of impurity. A silicon wafer is as large as 300 mm. These very large silicon wafers have helped to reduce manufacturing costs of transistors, the building block of ICs. Wafers for compound semiconductors, which are formed by two or more types of atoms, are much smaller, at most 150 mm. It took a few decades to increase the wafer diameter from the initial 20 mm to the widely used 300 mm. The wafer diameter has increased by 16 times, but the wafer area has increased by 250 times, reducing the cost per device drastically. Manufacturers have also overcome other challenges, including gaining a high degree of control over many parameters. For devices made using compound semiconductor, the manufacturing process involves depositing more semiconductor materials on top of the starting wafer. This is done during the crystal growth process, which is again carried out under highly controlled conditions. For all semiconductor devices, whether silicon or compound semiconductors, all the manufacturing processes following the wafer production demand a very high degree of cleanliness. After all, typical dopant concentrations used in semiconductor devices are in the region of 1 parts per million. These demands are placed not only on the manufacturing areas, called clean rooms for obvious reasons, but also on all raw materials deposited on the wafers and the machine parts that come into contact with the wafers during the manufacturing. The manufacturing lines have constant checks and scheduled maintenance to minimize costly downtimes. Therefore, semiconductor manufacturing requires skilled workers at all levels, from operators in the manufacturing lines to test engineers assessing manufacturing productivity and device reliability.